Hello everyone, welcome to part 3, the final part of this IA number 2 review. Once again, for calculations, please review these 4 steps of the problem solving strategy. So let's begin. Question 25 starts the whole circular motion unit. And when you have a stone on the end of a string rolled clockwise at a constant speed in a horizontal circle as shown in the diagram below. We got to figure out the pair of arrows that best represent the directions of the velocity and the acceleration. Okay, so our velocity is tangential, which means that's going to be drawn. If our circle is going clockwise, it's going to go downward this way, the velocity. And our acceleration, being that it's centripetal, means it's towards the center. So our acceleration is going to be along the string pointing towards the center. And when we look at the choices, the only one that fits is choice D. Number 26 asks for the centripetal acceleration of the object. So if we look into our equations in the reference table, we're going to get AC is equal to V squared over R. Our V is 4 meters per second. Our radius is 0.25. Plugging that all in, AC is equal to 64 meters per second squared. Choice D. Number 27 asks for the speed of the object, and we're given a force, a mass, and a radius. So we're going to use our centripetal force equation. Fc is equal to mass times V squared over R. Given that we're given a force, 40 newtons. We have our mass of 5 kilograms. We're looking for the speed, and our radius is 2 meters. Plugging that all in, V is equal to 4 meters per second, so that is choice D. Let's go over the math really quickly on this equation. So 2 times 40 gives us 80, which equals to 5V squared. 80 divided by 5 gives us 16, equals V squared, square root of 16. V is equal to 4 meters per second. And that's it. Number 28 involves some dummy variables. It's looking for the magnitude of the centripetal force, and the equation is Fc is equal to mv squared over r. It's asking if you double the speed. Let's take a look here. In the equation, our velocity is squared, and if you double that velocity, it's going to have a quadruple effect. You square that. And so the answer is choice D. If we write that down, because if you double the speed, this results in 4 times the force because V is squared. Number 29 asks for the direction of the centripetal force acting on the hammer. Okay, centripetal force, like the acceleration, they're directed towards the middle. And that middle is point A over here. So the answer is choice A, point A. Number 30 asks for the magnitude of the centripetal acceleration. Our equation is AC is equal to V squared over R. Our velocity is 4 meters per second. And we square that over our radius of 0.8 meters. So our centripetal acceleration will be equal to 20 meters per second squared. If we expand on that math, we're going to get 16 over 0.8. 16 divided by 0.8 should result in a higher number, 20. So that's choice D. 31 asks for how the mass affects the centripetal acceleration. If we look at our equation for centripetal acceleration, is there a mass in that equation? No. So the mass does not affect centripetal acceleration. It will remain the same. Number 32 asks for the magnitude of centripetal acceleration. So while we have it there, we can just plug in our values. Our velocity is, once again, 4 meters per second. And our radius is 4 meters. Let's expand on that math. 16 divided by 4, our centripetal acceleration is just 4 meters per second squared. Choice D. Number 33 asks for the magnitude of centripetal force. Fc is equal to mass times the velocity squared over the radius r. Let me write that equal sign. There we go. So our centripetal force is going to equal to our mass of 65 kilograms. Our velocity is 8.6 meters per second squared. Don't forget to square that. And our radius r is 2.5 meters. Let's expand on that math. Fc is equal to 65 times 8.6 squared, which is 73.96 all over 2.5. Plugging that all in should get you 1,922.96 newtons. And looking at our choices, they're all in scientific notation. The answer is choice B. Question 34 asks for the direction of the centripetal acceleration. If we look at our diagram, if the car started over here and it ends over here, it's going to go into this sort of path. That means the centripetal acceleration, wherever it is always directed towards the center, right here. So we got to draw the arrow. And the only acceptable answer would be pointing downwards towards the center. There we go. And let's just label that with AC to be more precise. Okay, now we have arrived at the very last two questions that are based on the same information. Okay, so 35 asks for the speed of the car. Our speed in a circular motion path is going to be 2 pi r over the period t. Our radius is 160 meters, and our period is 1 lap around the circular track in 36 seconds. Okay. So our r is 160 meters, and our t is equal to 36 seconds. So now we have all the information we need to solve for the velocity. So our velocity is equal to 2 pi times 160 meters over the period of 36 seconds. Doing the math, you should get 1005.3 on top over 36. The final answer is then 27.93 meters per second. Okay. Now we can calculate the magnitude centripetal acceleration using the equation. AC is equal to V squared over R. We have our velocity and we have our radius. Plug them in. 27.93 meters per second. And we square that over 160 meters. Centripetal acceleration is then. So when you square that and divide it by 160, you should get a centripetal acceleration of 4.87 meters per second squared. And that concludes our IA review. Hope that wasn't that bad. And guys, good luck on the IA.